All right, so I guess we'll jump right in. All right, so hello everyone. Thanks for getting here today. My name is Brad Satterthwaite, and I'm currently going through Parker's Technical Sales Training Program. As a part of that, I've been working with Air Hydropower for the past 2 months or so, and I represent Parker's Hydraulic and Fuel Filtration Division. So when I complete this program in July, I'll be a territory manager for Parker, similar to Colin Francis and Nick Grover, who also went through this program. My territory will be the Northeast, so I'm moving out east. I'm excited for that move. Should be a great experience. That being said, I'm working with Air Hydropower here for the rest of May. So if any of you guys have any projects or questions about filtration or anything kind of Parker, or really anything you just need another set of eyes or set of hands on, feel free to reach out. I've got my contact info at the end of this presentation for you. Also with that, I'm going to be sending out a copy of this presentation for you guys, so don't feel like you need to try to write everything down or anything like that. I'll get a copy to you so you can have that. So I guess we'll just go ahead and jump right in here. Today we're going to go through some of the basics of contamination, some of the different types, the impacts contamination can have, some of the different sources and prevention methods to help your systems run longer and better, and also some of the therapeutic products that Parker offers to help clean out any of the hydraulic systems that may get some of this contamination in them. So kind of what I went over last webinar, there's 4 main functions of hydraulic fluid. So any of these functions are really help you attain what you designed a hydraulic system for. So anytime there are impairments to these functions, your hydraulic system is not as you designed it to, or as you. All right. So one of the main ways that these functions can be impaired is through contamination. And over 75% of the hydraulic and lube system failures can be attributed to excessive contamination. So that's over 3 out of every 4 problems you see with a hydraulic system can be attributed to just contamination in the system. It doesn't have anything to do with the design of the system or what it's being used for, the application. It could be designed perfectly, but if you get contamination into the system, then you're going to see some failures and some problems and really have to deal with those headaches and issues. So there's 3 main types of contamination that you can get in a hydraulic system. The first being particulate, the second being water, and the third being air. So particulate is the most common contamination we'll see in a system. It's going to be in every system you see. It's really more about limiting the particulate and limiting the amount of large particles that are in your system. Water is another common contamination. It can cause some major problems. And then air is something that's kind of more on a specialty basis. It's not as common as the other 2, but it's still worth keeping an eye out for, and you need to be aware of the different prevention methods and different issues it can cause. So diving right in here to particulate contamination. One of the main sources of contamination is just built into the system. So I know Air Hydropower does a lot of work building hoses, building power units, and through that manufacturing process, you can get a lot of contamination in your system. So if you can have rubber particles from hoses and seals, just from cutting the hoses to the correct lengths. You can have dust just from the different components sitting around for a while before they get put in use. You can have welding slag and even sand from castings. Another contamination source is external to the hydraulic system, and it gets ingressed into that system itself. So here you see some ingression rates for typical systems in different environments. So I know we've all been to different plants. Some seem pretty clean, some are definitely not clean. But even in those super clean assembly facilities, you can still have between 100,000 and 1 million large particles ingressing into the system every minute. So, just because it looks clean, there's not dirt everywhere, you're still getting those particulate contaminations into the system. And you need to be actively preventing those from ingressing into your system. We also have generated contamination. So this is stuff that really just gets produced within the hydraulic system itself. So just to kind of highlight a few of the main ones here, the abrasive wear, that's just when there's existing particulate in the system and it runs through the system and it really just kind of scrapes and wears down on the different components. There's also fatigue wear. So that's just over time, pieces of the system itself are going to break apart. Nothing's going to be able to be perfectly new for its entire life. So it's just something to keep an eye out for. And then there's also erosive wear. So this fine particulate in the system, once you get it up to pressure and get it flowing at high rates, it can just slowly eat away at the components itself. So these are all things that as you get more particulate, they're going to increase in the rate that they're happening. So I know it's impossible to get zero particulate, but if you're able to limit the amount, you can really prevent these from building themselves up over time. There's also contamination from new fluid. I know I talked about this briefly in our last webinar, but any new fluid you get is not going to be clean. So as you can see here, product B and product C, in those little visual examinations, you can see that they're dirty. There's a bunch of particulate in them. And then if you compare that to our Parker's DuraClean fluid, which is packaged clean at ISO 151412, which is clean enough for most current hydraulic systems. That's really kind of a great starting point to be at. But those other ones at 22, 2014, and 25, 24, 21 are definitely too dirty for any new hydraulic system or any existing hydraulic system. So if you were to just take this oil, pour it from the bucket into the system, you're going to be putting all of that particulate into the system as well. And just a note here as well, just because the color looks like it's clean doesn't actually mean anything. If you look at those vials, you'd probably guess the middle one is the cleanest just because it's the lightest color. But pretty much every manufacturer is going to be coloring their oil to get to a color that they think the customer will think is clean. So everyone adds their own special blend of colors. It's not a good way to determine how clean your fluid is. So you really do need to pre-filter any of your fluid before you put it into your system. So just some basics that kind of covered last webinar, but wanted to remind you guys on. Different particulate sizes really falls into two different classes. We have silt, which are the small particles less than 5 micrometers in size. And these really generate system component failure over time. So they're not going to be something that as soon as you get them in there, you're going to see problems. But as they build up in the system, they can cause component failures. We also have chips, which are particles greater than 5 microns in size. So those can cause immediate catastrophic damage. So if you get those into your system, you can see some immediate problems. It's going to be definitely more of a problem. You want to focus on keeping those out of your system and filtering them out when you can. Some of the results that you may see from particulate contamination. So as soon as you get particulate contamination, your costs are going to start increasing, whether that's component replacement costs. Every time a component fails, you're going to have to pay to replace it. That can build up over time from just the cheap and expensive pieces all the way up to the high performance components that are really costly every time you replace them. You also have increased overall maintenance costs. So every time you got to do anything to the system, you're gonna have to pay someone to do it. And the more dirty your fluid is, the more often you're gonna have to have maintenance on the system, and that just builds up. You'll also have loss of production or downtime while you're doing those maintenance costs, so that just kind of compounds on itself. And then if you do let the particulate contamination build up, you're going to have a lot more frequent fluid replacement. So just buying the new fluid, but then also the costly fluid disposal for that old fluid that you're no longer using. And that fluid disposal is really going to be 3 or 4 times as much as just buying the new fluid. So that's kind of a cost sometimes that people don't necessarily see right away, but it's something to keep in mind, and it's definitely a major factor in lowering your costs when you keep your fluid clean. And just a little fun fact on here, the function of a hydraulic filter is to clean the oil, but it's really to reduce all of these operating costs and prevent the end user from having to make all these maintenance costs or loss of production. And it really eases everyone's mind on, they're paying to run the system. They're not wanting to pay to fix the system. So how can you tell if there is a particulate contamination problem? So a lot of warning signals can be seen, whether you have valve spool decentering, leakage, or chattering. You can have pump failure, loss of flow, or frequent replacement. You can have cylinder leakage and scoring, or servo hysteresis. So all of these are just pretty much every time you see them, they're going to be particulate contamination based. So if you see any of these, it's a great way to start the conversation with the customer of, dealing with the particulate contamination problem and getting it fixed right away. And so as far as particulate contamination detection goes, so if you see some of those warning systems and you really want to show that, yes, particulate contamination is a problem in the system, Parker does offer a bunch of particle detectors and monitors to really pinpoint exactly what the contamination level is. And we also have the bottle sampling PAR test, which is something you can take a sample from the system and mail it out to a lab, and they'll go through and give you a complete diagnostic of, here's what the particulate you're seeing, here's pretty much everything you need to know about the oil. So that's a great conversation starter you could use for a customer as well. As far as prevention methods goes, these are really kind of the easy, inexpensive ways to keep a system running at its top level as long as possible. So if you utilize reservoir air breathers, you can flush systems before initial startup. Like I said, keeping that built-in contamination to a minimum. You can kind of get it all out of the system before you bring it up to pressure. You can specify rod wipers and replace worn actuator seals. So anytime a cylinder extends, it's exposed to the environment, and then when it retracts, it's bringing all that particulate back into the system. So keeping those seals and rod wipers in a good condition and making sure they're on there can prevent a lot of that particulate from getting into the system. Another best practice would be to cap off hoses and manifolds. Really keeps the system in a closed system rather than exposing it to the environment. And you can also pre-filter all of your new fluid. Like I said, most new fluids are dirty. They're going to have particulate in it. So anytime you introduce new oil into a system, you're introducing new particulate. So if you're able to pre-filter it before you dump it into your system, you'll see a lot less particulate contamination. Moving on to some of the water contamination, a lot of the sources are similar to particulate. So if you have worn actuator seals, it can again bring in that contamination from the outside environment. A reservoir opening leakage, as you can see there on the picture on the right, if water's pooled up on top of your reservoir, it can get into any openings that may be on top for your breathers or openings in the reservoir, and that can contaminate your system. You can get condensation within your system, and you can also have heat exchanger leakage. If you're using a heat exchanger to cool down your oil, those can develop leaks, and that water can just kind of dump into your system. So some basics you need to know about water contamination. There are two main types. There's dissolved water and free water. So dissolved water is when the water content is below the oil's saturation point and you visually can't see the mixture. So a good comparison is how you can dissolve salt into water. It kind of just disappears and you can't see it. The same thing happens when you get water and oil. So there's a certain point at which the oil can dissolve all of the water, but once you get past that point, you'll start to see free water. And that's when that water content is above the saturation point of the oil, and it's generally going to separate into a separate layer over time. This example you see in the picture down at the bottom right shows what it looks like when it's in the system. It's all mixed up. It gives that kind of cloudy appearance. But if you were to let that sit and let it settle, you would definitely see two distinct layers of oil and water. So what happens when you get water contamination into your system? Some of the main things you may see are corrosion of metal surfaces. You can see accelerated abrasive wear, some bearing fatigue. You can see the fluid additive in the hydraulic fluid breaking down. There will be a viscosity variance, and there can be an increase in electrical conductivity. And so none of these are stuff you want to see in your system. The oil was designed to have certain properties that work well within a hydraulic system. So anytime you change those properties or introduce water and kind of mess with it, you're definitely going to see lower performance. And here we have it's a pretty handy chart just to see how well you can increase the relative life of mechanical equipment. So if you look at the initial ppm of a system, and let's say you have 5,000 ppm of water in your system, if you're able to decrease that down to 450 ppm, which is still usually above the saturation point for most hydraulic fluids. So this is just kind of separating out that water oil mixture, getting the water layer out. You can see a 4 times increase in your relative life of your mechanical equipment. So even just that kind of decanting or pouring off of that water layer can really help your system run a lot longer without seeing any of those failures that can be attributed to water in your oil. So how do you detect water? One of the main ways, kind of the easy and inexpensive way, is just visually. So if you take a sample from your system and you can see that cloudy appearance, or if you let the system sit for a while and you can see the water oil separation, that's the best way to know that you have a water problem. But beyond that, we do have moisture sensors, and our particle detectors, actually some of them do have water content options. If you really care about exactly what you're seeing and you want to pinpoint that to a certain level. And as well as with the particulate detection, the PAR test kit will give you a water content level as well. So that's another way you could get this information. So some of the prevention methods, again, these are kind of best practices, keep the water out of the system so you don't have to make any expensive repairs or expensive fixes to the system. One of the best ways is to utilize a desiccant air breather. So rather than just keeping a particulate air breather on there, this can get particulate and water. So any of the outside environment, water in the air will be absorbed by this media before it enters your system. Again, you can flush all your systems before initial startup. You're not really sure kind of what has been pulled up in your system while you were manufacturing it. You can also specify the rod wipers and replace the worn actuator seals for same reasons as particulate. You just want to keep all that outside contamination on the outside of your system. And again, cap off your hoses and manifolds to keep that system closed and don't allow any spots where outside contamination can enter. Moving into air contamination, some of the main sources can be system leaks, you can have pump aeration, and you can have reservoir fluid turbulence. So that reservoir fluid turbulence can basically be described as just splashing of the oil in your reservoir. That can kind of mix in some air with your oil and cause some bubbles and foaming problems. So just some basics of the different types of air contamination. You can have free air, which can be described just as a pocket of air trapped in your system. Dissolved air is just like dissolved water. So if you look at that first picture on the top left there, it's really, you can't tell that it's there. It's, you know, part of the oil. It's down on a molecular level, just contained within the oil. You can have entrained air, which are just the small bubbles dispersed throughout the fluid. And you can have foam, which are the large air bubbles on the surface of the fluid, as you can see there in the bottom left picture. So the main one you need to worry about here is the entrained air. That's kind of what gets into your system and what can cause the most problems. The foam will usually just sit on top of the surface of the fluid in the reservoir. It can cause some problems, you know, if it builds up and overflows or actually does get into the system. It can be problematic as well. And then free air can usually just be, I guess, removed from your system just by venting the system. And it kind of is, if you follow normal manufacturing and filling procedures, it's not going to be a problem in most cases. So what can you see from having air contamination in your hydraulic system? Some of the main ones, you can see a loss of transmitted power. So anytime you bring pressure up to the system, those air bubbles are all compressible. Well, the fluid is not. So if you bring it up to pressure, what you're actually doing is compressing those air bubbles before you can do any work. So that really just decreases your amount of transmitted power You're not going to see the results that you designed the system for, and you're not going to be happy with the performance. You can also see a reduced pump output. There can be a loss of lubrication. Again, introducing air into the oil changes the oil properties. It's not going to be working as it was designed to. You can see an increased operating temperature. So like I said, that air is getting compressed, and when you do that, that raises the temperature of that air, which can manifest itself into a higher operating temperature. Again, the reservoir fluid foaming, it can build up over time, and there may also be some chemical reactions that you could see, which definitely would change the composition of that hydraulic fluid. So how do you detect air contamination in your hydraulic fluid? The best way is just to do it visually. Some of the particle detectors and condition monitoring options we have can give you an error that looks similar to excessive water contamination, which can be a way to diagnose it, but really the most effective way is just to look for that foaming, look for those bubbles within the system. And if you have any problems or any applications that you think may be attributed to air contamination, you can always reach out to me or Colin Francis or Nick Grover to help you out with that. And so again, the prevention methods, which are the most important part to keep the air contamination out of your system. You can utilize system air bleeds to get rid of that free air like I was talking about. You really don't want to have any of those pockets of air in your hydraulic system. Use a flooded suction pump. That'll decrease the amount of pump aeration that's possible. Just having a proper reservoir design can keep the fluid from splashing around, and also utilizing return line diffusers. As you can see there on the top right, it keeps the fluid flowing a lot more steady. There's not going to be any turbulent flow as you see in the bottom right. You really want to keep it over in the laminar flow area with the nice, easy, straight lines. And so here we have a video coming up to go through what that proper design looks like. So at first you'll see the turbulent design. When the oil starts flowing, it's really, you can tell it's going to splash a lot when it falls down into the oil. But here you have the better way of designing it. So you can see the fluid is just kind of nice, easily pouring down the side of this diffuser right into the oil. There's no splashing. It's not going to aerate your system at all. And it really just will keep that air contamination to a minimum. And so here's just a close-up view of that. You can see there's very little splashing, but the oil is flowing down the side of that diffuser and just settling nice and easy into your reservoir. So to move into some of our therapeutic products, like I went over in our last webinar, the Hydraulic and Fuel Filtration Division likes to focus on total system health management. So we went through some of the diagnostic options for these different types of contamination. So if you're able to diagnose the system and really find out what's wrong, we offer a lot of therapeutic products that can fix the problem and get you back up to your healthy state operation of the system. And then once you utilize those to get the system back to running smoothly and running healthily, you need to utilize preventative methods to really keep that long-term value of the system and keep that contamination problem from happening again. So for particulate removal, we have the filter cart. It's great for reservoir polishing or fluid transfer. It uses a two-stage filtration, and there are IntelliCart options, upgrade options available. So that's just where you have the particle detector kind of hooked into that filter cart, so you can really see what your particulate contamination level is like. And it's also a great application for Pargel, which is our water removal media. So since it is just kind of a low flow application, that Pargel can get a lot of that free water out of your system just by sticking the hoses in your reservoir and filtering it through the cart. We also have the Guardian unit, which is a handheld fluid transfer product. So it's great for new fluid pre-filtration. You can put one hose down in your drum of oil and the other hose into your reservoir, and it'll pre-filter that fluid. It's great it's a nice lightweight option to really move around and carry around with you as you're filling up your hydraulic reservoirs. On top of those, we also have some 3-in-1 contamination removal. So these will get rid of water, particulate, and air contamination. So our first here is our PVS series, which uses our vacuum dehydration technology to get rid of the water contamination. And it's a portable unit, so you can take it from reservoir to reservoir, hydraulic system to hydraulic system as needed. And it really cleans up those systems, gets rid of all the free water and most of the dissolved water that you see within your system. We also have the Sentinel, which also uses the vacuum dehydration technology. It's a system controlled with ICANN, and it's really more intended to be an unattended automated batch process. So you just hook your system up, set your parameters that you want to keep your contamination under, and it'll kind of run itself and keep you below those levels. All right, so that's everything I've had here today. Do you guys have any questions about anything I went through, particulate, water, or air contamination? All right, it doesn't seem like it. Like I said, here is my contact info, Colin and Nick's contact info as well. If you do have any questions that come up or have any projects you want me to help out with, or in the future, if you need more filtration expertise, you can reach out to Colin or Nick depending on your territories. Thanks, everyone.
Randy, you did a really great job there.
Thank you, Randy. All right, I hope you guys all have a great day.